Hello everybody, and thank you for joining me in another recording. This time it's Edexcel's GCSE higher tier papers from November 2023 resit. So there's 3 papers, as ever, in any series, whether it be the summer or November resit. The first paper, this one, paper 1, is non-calculator. So put your calculators and even your phones, I suppose, to one side and try these questions without use of any calculator. So what I'm going to do, I'm going to explain how to do every single question, sometimes with more than one method, but I'm going to try to strike a balance, as ever, in between making the video fairly quick and punchy without being too quick so that I lose or confuse people, yet on the other hand not so slow that I sound overly boring, overly laborious, and a bit too much detail so it can even be confusing. So I'm trying to strike that balance. Let me know, as ever, if I get it slightly wrong. I'm always welcome to constructive criticism. Anyway, that's enough for me. Let's make a start. Let's do question 1 together. Question 1, we have to work out 6.3 multiplied by 2.4. Question 1s are normally fairly straightforward as long as we don't panic. So what we're going to do here is realise the key operation we're doing with these decimals is multiplication. And for the meantime, what I'm going to do is actually pretend these decimals aren't there. So I'm going to think of this question as 63 multiplied by 24 first. So 63 multiplied by 24, and with multiplication there are different methods we can use. So I'm just going to recap the 3 main ways in my mind of how we can multiply numbers together. I'm not saying there are only 3 ways, there are many more than 3, but the primary 3 ways, in my opinion, are as follows. So we're thinking of this as 63 multiplied by 24, as I say. We'll worry about these decimals at the end. So I'm just thinking of it as 63 times 24. The first method of the 3 is the column method. This is the way I was taught, and actually isn't the way I now like to do it. So first of all, we use the bottom right number 4. We do 4 times 3, which is 12, put 2, carry over 1. Now we do the bottom right number times the next one above it, which is 6. 4 multiplied by 6 is 24, plus 1 here gives 25. So 2 and 5. Just take care that you write the numbers in line in column order. The next number I'm going to multiply at the bottom is the 2, which stands for 20, to 0. So I'm going to put a 0 here as a placeholder. So now we're going to do 2 multiplied by 3, which gives 6. Finally, 2 multiplied by the 6 there gives 12. So just write 1, 2. Now the only thing left to do is to add these 2 numbers together. So 2 add 0 is just 2. 5 plus 6 is 11. Carry over 1 over. 2 plus 2 plus a carried 1 is 5. Plus 1 on its end. I've got 1,512. As I say, I'll mention how to deal with these decimals at the end. Another method for multiplication is the grid method. So using the grid method, we'd write 63 in tens and units, and similar with 20 and 4. So the first box, in fact we can do the boxes in any order. So forget the zeros and tell the end bit. So if I take this box for example, I can think of this as just 2 multiplied by 6, which is 12. But I've got a 0 here and a 0 there, so 2 zeros. So I add in 2 zeros like that. For this box I'm going to choose to do next. 3 times 2 is 6, but because it's a 0 there, add on the 0. This one, 4 times 6, 24, plus the 0 in the 60. And finally 4 times 3 is 12. Then if I add all these numbers together, I can do this in any order I like, but what I'm thinking here is these 2 here add together quite nicely because they make exactly 300. So that's going to give me the 1200 plus the 300, which I've highlighted in the yellow, plus the 12 at the corner. It's annoyed me how it's not highlighted, all of it like so. 1200 plus 300, of course, 1500 plus 12, again gives 1512. Finally, the lattice method, sometimes called the Chinese method. I split the boxes diagonally from corner to corner. And again, these boxes can be done in any order. So if I go for this one here, for example, I do 3 multiplied by 2, which is 6. 0 tens, 6 units. this box here, I'm going to do 3 multiplied by 4, which gives 12. This box, 6 times 2, again gives 12. And finally, this bottom corner, 6 multiplied by 4, gives 24. I then imagine these numbers sort of going down a slide and landing in a pile together, combined at the bottom. So starting from this end, that's just a 2, so I've just got 2 here. This bit, 6 plus 1 plus 4, 6 plus 1 is 7, plus 4 is 11, so put 1, carry an extra 1 along. This one, 2 plus a carried 1 is 5, then just 1 on its own gives 1. So again, I get 1, 5, 1, 2. So I get the same value each time, 1,512, but again, the key point is where to put this decimal. In the question, count the digits which come after the decimal point. So here there's 1 digit after that decimal. Over here, the 4 comes after this decimal. So I've got 2 digits after the decimals in my question. Therefore, I need 2 digits after the decimal in my answer. So after the 2, after the 1, sorry, before the 2, before the 1 I mean. So the answer needs to be 15.12. No matter which way we've used, each method needs to give us 15.12. So we'd get a mark for getting 1,512, and then we also need to remember to place the dot in the correct position. If you don't like this method about where to place the dot, simply round your answer to get a feel for how big the final answer should be. So round these values, that's about 6, that's very roughly 2. So my answer needs to be very roughly what 6 times 2 is, so it needs to be in the region of 12. I couldn't put a decimal anywhere else with the number being anywhere near to 12. That's the closest to 12 I can get it by putting the decimal in the middle, so that's another way how you can think about where the decimal needs to go to make the answer make sense. Question 2. Write down the value of 5 to the 0. Well, we need to remember that anything to the power 0 equals 1. Anything to the power 0 is 1, so this here is just simply 1. The next one here, write down the value of 5 to the minus 2. My suggestion with negative powers is to leave the negatives till last and treat the power as positive. So 5 squared, taking this 2 as a positive 2, not a negative, 5 squared equals 25. Therefore, if we know what a value is to the positive version of the power, that value to the negative version of the same power is just the reciprocal of the answer of what we got when that power was its positive version. So 5 squared is 25, so 5 to the minus 2 will be the reciprocal of 25, which just means 1 over 25. So to clarify, the laws I've used here for indices, where a is any number, a to the 0 is always 1. That's what I've used there. And the law I've used here is any number to a negative power is the same as 1 over that thing with a power made positive. Part B, we need to write this in the form 2 to the n, where n is an integer. Well, the first thing to note is the top of the fraction, we're multiplying 2 powers. So we can just add these 2 powers together. 2 to the 5 times 2 to the 4 becomes 2 to the power of 9. Then dividing that by 2 to the 3. When we're multiplying, we add the powers together. Opposite of multiplying is dividing. So when we're dividing with powers, we do the opposite thing, which is to say that we're going to subtract 1 power from the other. So as an overall power of 2, we're going to have 2 to the power of 9 take away that power of 3. But of course, 9 take away 3 is 6. So answering the question, where we leave it as a power of 2, so it's 2 to the power n. In our case, the n is 6. As a simplified power of 2, this just becomes 2 to the power of 6. Question 3. Write 156 as a product of its prime factors. Some teachers, myself included, sometimes call this doing a prime factor tree. So we're going to start with the number 156. We then need to think of any number we want, we can divide that by, apart from going for 1, because you can divide anything by 1, so that's not saying anything. If a number's even, I always go for dividing it by 2 out of habit. So I'm going to divide that by 2, and the answer to that is 78. And this is how a prime factor tree works. On one hand is what you're dividing it by, on the other is what you get after dividing it by that number. In other words, 156 divided by 2 is 78. And if I get a number in the tree which is a prime number, I circle it and leave it alone. So 2 is prime, so that's going to be circled, that's a dead end, that branch is complete. 78 though isn't prime because you can divide that by 2. So my next step, I'm going to choose to divide this by 2, which will give 39. Again, 2 is prime, so same step, I ring that, I circle it and I leave it, and now deal with a 39. 39 isn't prime, it might look like it, but it's not, because 39 is in the 3 times table, which means that I can divide it by 3, which gives me 13. Both 3 and 13 are prime, and so every branch is now a dead end, which means our question is pretty much complete. So as a product of its primes, 156 is all of these circled yellow numbers all multiplied together in one string. In other words, 156 is 2 times 2 times 3 times 13, which is written in its best form as 2 squared multiplied by 3 multiplied by 13. Part B, if you notice of Part B, we're using the same number, so the answer to Part A will help us here to answer Part B. We want the highest common factor of 156 and 130. Before I continue, there's a little sort of tip I always give students. If you're trying to find the highest common factor of 2 numbers, the highest common factor of 2 numbers will always be a factor of the gap in between those 2 numbers. So the gap in between these 2 numbers is 26, and so the HCF of these 2 numbers must also be a factor of 26. So what you could do is start by thinking, well, does 26 fit into 156 and 130? And if not, what about factors of 26, which is the biggest one, fits into these 2? But I'm going to give you the most standard way of doing this question, which is actually a Venn diagram. So first of all, we're going to split 130 into its prime factors, similar to what we did with 156. So 130, again, my habit is if it's even, I divide it by 2, I get 65. 2 is prime, so I circle it. 5 isn't, so 65 isn't, because I can divide this by 5, which gives 13. Both 5 and 13 are primes, and so this is the prime factorisation of 130 complete. 130 is 2 times 5 times 13. We can now put this into a Venn diagram. The middle overlapping section are the factors which are common to both 156 and 130, and we put these in here first. And so in 156 and 130, there's a factor of 2 in each. So 1, 2 in each. We can also see, though, there's a 13 in each of these. So common to each is a 2 and a 13. So in the middle, I'm going to put a 2 and 13. So 156, what is just in 156 and not in 130 are the other 2 and the other 3. So 2 and 3 go here for 156, and for 130, 2 and 13 we've got, which just leaves a 5 in the section which is just factors of 130. Now, because we want the highest common factor, what we want here is to multiply just the middle section, the middle numbers here, we times these together. If, by the way, we wanted the lowest common multiple, that's where we multiply all of these numbers by each other. But for the HCF, all we need is to multiply the 2 numbers in the middle together, so 2 times 13 gives 26. Therefore, the highest common factor of 156 and 130 is 2 times 13, which gives 26. If you remember what I said earlier, you could also have considered what the gap in between 156 and 130 is, which is 26, and then testing if 26 or factors of that fit into 156 and 130. Coincidentally, the highest common factor of both these numbers was actually the gap in between them both. The highest common factor was 26. Another method you could use, which I'm not going to go into now, you could do prime factor diagrams, sometimes called factor bugs or factor spiders of each number, and then just seeing what the biggest factor you find in each is. But I'm going to leave it for there because I think the quickest and probably best way of doing this is by using a Venn diagram. Question 4. The mean length of 5 sticks is 4.2 centimetres. Narwhal measured the length of one of these sticks is 7 centimetres. Work out the mean length of the other 4 sticks. Slightly hard sounding for question 4 this. Well, we're talking about mean, so what calculation or equation do we know which relates to the mean? Well, the mean is the total of things divided by the number of things. So because we're talking about lengths of sticks, the mean length of a stick is going to be the total of the lengths of the sticks divided by the number of those sticks. So we're told the mean length of 5 of them is 4.2. So we know the mean, and we know there's 5 of them. Therefore, we could work out the total lengths of all 5 sticks. So if I cover up the total of the lengths, and so what's left, I've got the mean next to the number, 2 things next to each other means I'm going to multiply one by the other. So the total length of all 5 sticks will be the mean of those 5 multiplied by 5. In other words, the total lengths of those sticks is 4.2 multiplied by 5, which is 21 centimetres. However, we want the mean length of the other 4 sticks. So this isn't our final answer. So if one of the sticks was 7, how long in total would the other 4 have been? So if I were to do 21 subtract 7, that means that the other 4 sticks must have had a total length of 14 centimetres between them. So if I've got 4 other sticks with a total length of 14, the mean length of those 4 remaining sticks must be 14 divided by 4, which gives 3.5. So the mean length of the other 4 sticks will be 3.5 centimetres. For part B, we're told that Narwhal has made a mistake. The stick wasn't 7 centimetres long, it was actually 17. How does this affect your answer to part A? Well, part A, we took away the length of the other stick and then divided that by 4. So we took away 7 and then divided by 4. If actually the other length of the stick wasn't 7 but was 17, what we should have done was take away 17 and then divided by 4. So 21 take away 17, but I'd only leave those of 4. Then 4 divided by 4 would be 1. So because we'd be taking away a bigger amount and then dividing, we'd end up with a smaller total after we've done the final division, which is a long-winded way of me saying the answer to part A would be smaller. If in doubt, if you're not sure how to word it, do the calculation yourself with the new information, then compare and say if it's bigger or smaller and how the answer has been affected. But to keep it short and sweet, just say my answer. In other words, the mean of the other 4 sticks would be smaller. Question 5, possibly my least favourite type of questions, constructions and loci, things you need to do with a compass and protractor. So, we've got here point P, which lies on the straight line from A to B. We need to use ruler and compasses to construct an angle of 90 degrees at P. Read the question carefully. You're not going to get any marks if you don't show evidence of using a ruler and compasses. In other words, what you need to leave on your diagram is clear arcs, ARCS, in other words, the curves where you've used your compass. And it's no good trying to pretend you've used a compass by adding on pretend arcs. If you're a good artist, the examiner will know if they're proper arcs or not. So you need to use a compass. So I'm going to show you how to do it. So first of all, what we're going to do is we're going to get our compass and we're going to put the compass at the point P. So in terms of the distance, the width of the compass, I'd suggest to make it somewhere so it's not as long as from A to P, but almost as long. What we're wanting to do is make 2 little arcs either side of P, which are an equal distance from each other. So if I go leave a needle at P, so I'm going to make a mark there, and then if I spin the compass around, make another mark there. So I've got two arcs which now denote, which mean these 2 points are the same distance away from P. Now what I'm going to do is I'm going to widen my compass slightly. So I'm going to put the needle on one bit where it crossed the line from A to B, and I'm going to make it about 3/4 the width from one arc to the other. Now, it doesn't need to be 3/4 or 2/3, doesn't really matter, but it needs to be over halfway is the main thing. So I'm going to go for about there. I'm going to change the colour of this pen now to a blue, just so that you can clearly see where the different bits are coming from. So now what I'm going to do is I'm going to make a sweeping arc above and below P, like this, all the way above and below like so. Then I'm going to switch sides and do the exact same thing from the other arc, keeping the compass width the same at this point. So we've got that. The final step is now to do a straight line through where these blue arcs have crossed. So if I do this in a different coloured line, maybe a green, then you'll see, if I do this, it's going to be a straight line going through P. Mine's not quite perfect. I'm always pleased when it is. But that there, the green line, is a 90-degree angle cutting through P, which goes through line AB perpendicularly. So that's question 5 done. If you're not sure with these or you lack confidence, I'd massively suggest practicing your constructions and loci and get yourself a compass and protractor if you've not got one already, and practice, practice, practice. Question 6 is about angles in triangles and on straight lines. It just says here to work out the value of W, which is this angle here at B. In other words, W is the angle CBD, looking at it from this side. It just says to work out the value of W, so don't need to worry too much. In fact, for this one, don't need to worry at all about giving reasons for our answers. For example, angles in a triangle add up to 180, alternate angles are equal, and all that stuff. We can just set to and work it out directly. So where to start? Well, first of all, it says BA is the same as BD. So BA means the line from B to A, and BD means the line from B to D. And in fairness, this has already been told to us by these dashes on the sides of this triangle. These dashes means that the side BD and BA are equal. Therefore, if the triangle has two equal sides, it's going to be isosceles. But to emphasize this fact, I'm going to label these on in blue just to make the point even clearer, because it's very, very important. So we've got an isosceles triangle. Two sides are the same, therefore the two angles at the base are the same. Now, base angles is a term which can be quite confusing to students. Base angle means the two angles which are identical. I think of this in terms of which angle isn't going to be the same. The odd one out, the different angle, is always where the two equal sides meet. And so y is going to be the different angle, therefore these two here at D and A are going to be the same. So if A is x degrees, D will be x degrees as well, because it's an isosceles triangle. We're then told that the ratio of x to y is 2 to 1. Now, ratios can be slightly confusing because they work like fractions, but you need to take care when doing so. In plain English, this means for every one lot of y, x is worth 2 lots. And so x is twice as big as y. So as long as we remember that fact that x is double the size of y, we're good to go. So the next step, if I just call these angles x 2y, I can now formulate an equation for the angles inside this triangle, which we know should equal 180 degrees. In other words, x plus y adds up to 180 degrees. So if I just colour code x in yellow and y in green, we've got this equation here. X plus y is 180. But using the fact that x is 2 lots of y, we can write this equation all in terms of y, and we get this. 2y plus this y here adds up to 180. Simplifying, we've got 5y's equal 180. To work out what 1y is, we can divide both sides by 5. So y will be 180 divided by 5, which will give us 36. I'll very quickly show you how to get 36 if you're not sure. So using the bus stop method rather, how many 5s fit into 180? Well, 5 into 1 doesn't go. Therefore, we've got a remainder of 1. So that 8 is now 18. 5s into 18, we can fit 3 of them. 3 5s is 15. 15 is 3 away from 18, so the next remainder is 3. Finally, 5s into 30 goes 6 exactly. Because it's 6 exactly, we're done. Hence, like I say, that's why y is 36 degrees. But we don't want y, we want to work out w. So we need to remember that CBA is a straight line, well, ABC. So therefore, y and w are angles on the same side of a straight line. So we need to remember now that angles on the same side of a straight line add up to 180 degrees. Therefore, w is going to be 180 minus 36, which will be 144 degrees. Question 7. Mano has 3 shelves of books. There are x books on shelf A, 3x plus 1 on B, and 2x minus 5 books on shelf C. There's a total of 44 books altogether on the 3 shelves. All the books have the same mass. The books on shelf B have a total mass of 7,500 grams. Work out the total mass of the books on shelf A. So, this one is essentially a problem-solving type question. So there's 3 different shelves, A, B, and C. So I'm going to colour code these yellow, green, and blue. So there's a total of 44 books. So x plus 3x plus 1 plus 2x minus 5 should add up to a total of 44. So we can get an equation from this. So this is the suggested starting point. X plus 3x plus 1 plus 2x minus 5 equals 44. We can now simplify this. Grouping together all the x's, x plus 3x plus 2x gives 6x, and 1 minus 5 is minus 4. So 6x minus 4 equals 44. We can now solve this for x. So the next step I'm going to suggest we do is to add 4 to both sides. And if we add 4 to both sides, we get that 6x must be 48. Now if we divide both sides by 6, we see that x will have to be 8. In other words, there's 8 books on shelf A. But the next thing it's mentioning, in terms of useful information, is the mass of books on shelf B. It says shelf B, the total mass of those books is 7,500. But on shelf B, there is 3x plus 1 books. But since we know what x is, we can now substitute x is 8 to work out how many books there are on shelf B. So for shelf B, there's 3 lots of x, which means 3 lots of 8, plus 1, which means there's 25 books on shelf B. And we know, of course, that those books have a total mass of 7,500 grams. In other words, 25 books weigh 7,500 grams. What I'm now going to suggest we might want to do is to work out the mass of 1 book. Then once we've got the mass of 1, we can scale up to find how many the weight is on shelf A. So to find the mass of 1 book, we could divide both sides of this by 25. So 1 book is going to be 7,500 divided by 25. My suggestion for this, because it's a non-calculator exam, is to ignore the zeros and see how many times 25 fits into 75. Well, 25 goes into 75 3 times, then add on these 2 zeros, that gives 300 grams. So 1 book is 300 grams. However, we want to work out the total mass of books on shelf A. Well, shelf A is when we've got x books, and we know that x is 8. So we want the mass of 8 books. So to go from the mass of 1 book to the mass of 8, we can multiply this by 8 on both sides. Therefore, multiplying by 8, we see that 8 books, in other words, x books on shelf A, that must be 300 times 8, which is 2,400 grams. So we got what x was by using purely algebra. So if you're not an algebra fan, I'm going to show you a very useful way if algebra freaks you out still, or you have a moment of panic or being unsure in the exam. What you could do is just try some values for x. So once you've got what x is, but x is 8, the next step is going to be the same. But if you're not sure how to get into the question, just be thinking, the books have to be a whole number. It'd be nonsensical to have like 1.7 numbers of books. So be thinking whole numbers for x. If I look at shelf C, x has got to be at least 3, because if like x was 2, that'd give 2 times 2 minus 5. You can't have a negative number of books. So what we could try is x being equal to 3. So if x was 3, just for example, on B, it's going to be 3 times x, so 3 times 3 plus 1, that would give 10 for B. And then on shelf C, 2 times 3 is 6, minus 5 gives 1. Then we can just check if that totals up to 44. 3 plus 10 plus 1, that gives 14. It's too low, so then we can just try a bigger number. So let's say, for example, 6. If x was 6, on shelf B, it would be 3 times 6 plus 1, which is 19. Then on C, 2 times 6, 12, minus 5, which gives 7. Does that total up? It won't do. Again, it'll be too small. That'll give a total of 32. But if you keep going, for example, if you tried 8, 3 times 8 plus 1 is 25. And then 2 times 8, 16, minus 5, which gives 11. 8 plus 25 is 33, plus 11 is 44. That is a valid way of answering the question. It doesn't say you must use algebra. Don't get me wrong, algebra is what I definitely suggest you do. But then you've got there that there's 25 books on shelf B, then you can proceed as normal. So any way you can answer the question, do it. The more ways you know, the more weapons you have in your arsenal to attack the questions. Know as many methods as you can, even if, when all's said and done, you have your one favourite method which you'd rather use more than the others. Question 8. Price of a mattress. How exciting. So, we've got the normal price of a mattress is reduced by 40% in a sale. Sounds too good to be true. Let's go and buy ourselves a mattress. The price of a mattress in the sale is £660. We need to work out the normal price of this mattress. So, it's been reduced by 40%. That's the key piece of information. So, let's think what that means. Essentially, if 40% comes off a price, that means 60% of the normal price remains. So a different way of saying this would be that the actual sale price is 60% of the original. And 60% of the original, we're told, is £660 because that's the sale price. So this is our way into the question. If 40% comes off, 60% remains, and the 60% that remains must equal £660. So 660 quid is 60% of the normal price. To find the normal price is going to be 100% of itself, of course. So we need to scale this from being 60% up to 100%. But 60% is a fairly awkward number. I can't just times it by something to get to 100. Not very easily anyway. But what I could do is maybe find 10% or even 1%. I'm going to find 10% next because then I can multiply by 10 after to get it to 100%. So here I can divide both sides of this by 6. Dividing both sides by 6, that tells me that £110 must be 10% of the normal price. Once I've got 10%, I can now multiply both sides by 10 to get 100%. Therefore, £110 multiplied by 10 tells us that the normal price must be £1,100 or £1,100 if you prefer to say it that way. Question 9. I personally do not agree with question 9 at all, because in my opinion you need at least double the number of cups of rice, double the number of cups of water for each lot of rice you use, otherwise there isn't enough water to go in. But anyway, Me taking my chef hat off for a second, I'm going to ignore the reality of this question. Maybe it's a different type of rice. I'm going to stop babbling and talk about this actual question we've got. It's a ratio, essentially, okay? So number of cups of rice you use, which is x, as a ratio of number of cups of water to go with them, is in the ratio 4 to 5. And we need to draw a graph to show the relationship between the number of cups of rice and the number of cups of water needed to cook it. So just be thinking, cups of rice, x is along, so 4 along, and y goes up 5. So what it's saying is, if you had 4 cups of rice, you'd need 5 cups of water. So that gives us essentially our first coordinate point to plot. So if I go along 4 for x and up 5 for y, I can plot this point here. And that point specifies that if I were to use 4 cups of rice, I'd use 5 cups of water. If you want another point, that's easy enough. You could just double these numbers. If I had 8 cups of rice, I'd be needing 10 cups of water. So if I add on another point here, and then don't forget common sense. If you're cooking 0 cups of rice, in other words, if you're cooking nothing at all, you would need no cups of water. No rice, no water. So in other words, the graph, when we draw it, needs to go through 0, 0. So adding this information together and drawing a straight line through these 2 points, and importantly through 0, because this is a relationship of direct proportionality, we need a straight line looking like this. For B part 1, we now need to find the gradient of the line we've just drawn, but this is actually easier than what you may imagine, because a lot of information is being given here. If I just focus on this triangle here with the green base and the blue side perpendicular, I can work out the gradient from this bit here. So what is the gradient? How do I calculate it? Well, the gradient in between any 2 points is the change in the y values divided by the change in the x values. So from 0, 0 up to that point, y is increased from 0 up to 5, and x is increased from 0 to 4, so that's an increase of 4. So put simply, the gradient is just 5 over 4, and that's a valid way to leave our answer. If you prefer, you can do it as a decimal. 5 over 4 means 5 divided by 4, which gives 1.25. We now need to explain what the gradient represents. Well, another way of conceptualizing the gradient is it tells us the increase in y for every 1 unit we increase x. So x, we're talking about numbers of cups of rice. So for every additional cup of water, for every additional cup of rice we have, we need to increase the cups of water by 1.25. I can put this more simply. It just means how many cups of water we need for each cup of rice used. So all we need to say is something like this. It represents how many cups of water are needed for 1 cup of rice. Question 10, we're talking about circles. So this time it says the circumference of a circle is 10 meters. We need to work out the area of a circle, giving our answer in terms of pi. So I'm just going to suggest we can maybe sketch out a circle here. So circumference. I'm going to highlight this in green. Circumference means all the way around the outside of a circle. So here's a circle. In red is the center. Well, roughly the center, it's not perfect. And green is the circumference. So what this means is the length all the way around the outside of a circle is 10 meters. So to emphasize this, there we go, that's 10 meters. But we don't want the circumference, we've been asked to work out the area. So we need to remember 2 main formulas. The first one, for circumference equals pi multiplied by the diameter of the circle. Whereas the area equals pi multiplied by the radius of a circle squared. The silly way I remember it is in terms of pies. Chicken pies delicious, apple pies are too. There is of course a circle song, and heaven knows what else number of ways of remembering these two very important formulae, but that's the way I remember it because I like pies, sadly. Anyhow, so we've got the circumference, which is pi multiplied by the diameter. So we can substitute in to this formula because we know the circumference is 10. So circumference, which is 10, equals pi multiplied by the diameter. Therefore, I can work out what the diameter is. The diameter is all the way from one end to the other of the circle. So if I just label on the diameter here, then I can put in what it is in a second. If I divide both sides of this by pi, that will leave the diameter all on its own, which is what I'd like to do. So the diameter of the circle is just going to be 10 divided by pi. So if I label this on now, diameter is 10 divided by pi. I'm wanting the area, and to get the area, I don't want the diameter, I want to work out what the radius is. Now the radius of a circle is just from the centre going to the edge. It's that length from the centre to the edge. In other words, the radius is half of the diameter. So once I've got the diameter as 10 over pi, if I half that, I get the radius. So half of 10 over pi, I just half the denominator. So the radius is going to be 5 over pi. Now I can work out the area, leaving it in terms of pi. So the area is pi r squared. That's going to be pi. And the radius is 5 over pi. So I've got pi here, but I've got this fraction all squared. So I'm going to square the top and square the bottom. So 5 squared, of course, is 25. Pi squared, because I want to leave it in terms of pi, I'm not going to even attempt to work that out. I'm just going to leave it as a symbol pi, all squared. Finally, need to be a bit careful. I've got a pi here, I'm dividing it by pi, which will cancel it, then I'm dividing by pi again. So this will actually simplify to 25 divided by pi. So we need to take a bit of care with this question, to say the least. Question 11 is about a box plot. So Alice recorded the number of cars going into a village on each of 80 days. The incomplete table and the incomplete box plot give information about her results. So table, box plot, both partially complete. So part A comes in two different parts. A part 1, use the information in the table to complete the box plot. So use information we've got here. So we've got the box beginning and end. So what this means is this is the lower quartile, that's the upper quartile. So what we don't have yet is the least number drawn in on the box plot. But we do know here the least number is 300. So we can add in a vertical line at the point 300 to denote the minimum value. So that's the end, the first end of a box plot. The next point we can use is the median. The median's at 900. So again, similar to what we did before, a vertical line at 900 to note where the median is. So the median splits this box into 1/4ish and 3/4 that side. So median at 900. Finally, and this is where you need to be careful, it's tempting to just add in the range and do another vertical mark at 1000, but actually not quite. A box plot always has 5 values that are plot on it. So the least value lower quartile, median and upper quartile, but the largest value is the final thing that's plotted, not the range. However, we do know the least value is 300 and the range is 1000. And knowing that the range is the biggest to take the smallest, from these two we can work out what the maximum value must have been. So essentially, if there's a gap of 1000 in between the least and the greatest value must be 300 plus 1000, which is 1300. So the greatest value is the least plus the range in between it, which gives 1300. And so the final line we need to draw, the final vertical line I should say, is a vertical line going straight down at 1300. That's almost complete, but we need to remember a box plot is only fully drawn when we have horizontal lines from the end of the box to the least value, and from the right hand end of the box, horizontal line going to the greatest value. So to complete it, we add on two horizontal lines like so, and that's the completed box plot. A part 2, we now need to use the information in this box plot to complete the table. So looking at the table, the only two bits we need to include are the lower and upper quartile, and these are always given by where the ends of the boxes are. So the left-hand side of the box, that's where the lower quartile is, and the right-hand side of the box, that's where the upper quartile is. So reading down from these 2 points, the lower quartile, well, each little square going along must be worth 20. That's 700, 720, 40, 60. That's at 780, and the upper quartile is at exactly 1200. So we fill in these values like so, and then we've done A part 2. For part B, it says on some of these 80 days, Alice saw fewer than 1200 cars going into the village. 1200 is a crucial value in our box plot. 1200 is the value at the upper quartile. So we're going to use that knowledge to work out an estimate for the number of days Alice saw fewer than 1200 cars going into the village. So quartiles, essentially, like the name suggests, quartiles sounds rather like a quarter. The quartiles split the data into quarters. So essentially, from the lowest to the lower quartile, that's the first quarter of data. In between the lower quartile and the median, that's the second quarter, or 25%. Between the median and upper quartile, that's another 25%, or another quartile. And from the upper quartile to the maximum value, that's the final highest quarter of data. So we can call it quarters, or 25% each time. But we're only interested, for our estimate, the number of days Alice saw fewer than 1200 cars. So we're looking at 1200 downwards, so all the way up to 1200 but not beyond. So it's highlighting yellow for a bit of this box plot we're interested in. We're interested in essentially this section here. So it's 75% of the recorded data is our best estimate for the number of cars, fewer than 1200 cars. So we need to just take the total number of cars recorded, total number of days, get myself confused here. Total number of days is 80, my bad. And we're wanting essentially 75% of those 80 days for our estimate. So finally, 75% of 80 days, or 3/4 of 80, same thing, is 60. So the number of days you saw fewer than 1200 cars going into the village is 60, and therefore the number of days where it'd be more than 1200 cars, it'd be 1/4 of 80, that would be the other 20 cars at the higher end. Question 12 is about straight lines. So we've got straight line L with equation 2y equals 3x minus 7, and we need to find an equation of a straight line perpendicular to line L that passes through 6 minus 5. The first thing I'd mention to students of my own would be to remind themselves what is the best and most famous form of any equation of a straight line, and it's always going to begin y, as in y equals mx plus c. This one doesn't begin with y as a subject, this is 2y. So what I'd suggest doing strongly is to get this equation into a more familiar form by dividing both sides of this by 2. And if we do that, we see that the best form of line L is y equals 3 over 2x minus 7 over 2, just by dividing everything by 2. Now, we want to find an equation of a straight line perpendicular to this one and passes through this point given. Now, I'm going to borrow an idea from Mr. O'Grady here, which I'm going to use myself in future because many students get confused about which bits of this equation we can essentially borrow to move forward to answer the rest of the question. The key thing here is perpendicular. Perpendicular means it affects the gradient of the line it's perpendicular to. So we don't actually need to consider the y-axis intercept. This part of line L we don't need in order to answer the rest of the question. So I'm just going to scrub off essentially that bit. We're going to borrow the gradient. So what do we mean by borrow the gradient? Thank you to O'Grady for this as well. We need to remember what perpendicular means in relation to gradients. So if we want a line perpendicular to one given, we need to remember what we need to do to this gradient. It's two magical words. We need to remember to take the negative reciprocal of the original gradient, which in plain English means we take this fraction, flip it on its head, and switch its sign from positive to negative, or if it were negative, which it's not, we go from negative to positive. So this here, this gradient of the perpendicular line will be negative 2/3. We don't know yet what the y-axis intercept of this line perpendicular to L is, so I'm just going to leave that as plus c. So the equation of the line we're trying to find will have this form. Its gradient is a negative reciprocal of the gradient of L, so 3 over 2 becomes minus 2/3, the negative reciprocal. We just need to find where it crosses the y-axis. Luckily for us, we do know some extra information about x and y. So we know a value of x and y because we've been given a coordinate pair. So we know when x is minus 5, sorry, when x is 6, I mean to say, y is negative 5. So using these values, we can substitute them in. So y, we can sub in minus 5, and for x, we can sub in 6. So our next line is minus 5 equals minus 2/3 of x, which is 6, plus c. Well, 1/3 of 6 would be 2, so 2/3 would be 4. If 2/3 of 6 is 4, minus 2/3 of 6 is minus 4. So simplifying this slightly, we get minus 5 equals minus 4 plus c. To get c on its own, we could add 4 to both sides of this equation, like so. Therefore, c is going to be minus 5 plus 4, which takes us to minus 1. So we know the gradient, the negative reciprocal of the original, is negative 2/3. We've now worked out c is minus 1. We've worked out the new m and the new c. So we've got both parts of the ingredients to give the full equation of a line. So finishing off now, we can say that this line must have equation y equals minus 2/3 of an x minus 1. Question 13, the key word that should jump out at you is similar. A and B are two solid similar shapes. We've got the ratio of heights of solid A to solid B is 2.5, and then we're told the volume of solid A is 12 cubic centimeters. From this information, we need to work out the volume of solid B. So, if we're talking similar shapes, and it's not just in terms of lengths, but maybe areas and volumes, I would always strongly suggest making a table out of it, something like this. So solid A and solid B, then 3 different rows for the length ratio, the area ratio, and the volume ratio. And the key ratio to begin with, if possible, is always the length ratio. And luckily we've been told this. You might be thinking, well, we're told height, it's not a length. Well, length, width, and height are all measures of distance, essentially. So I could call this a DAV table if you wanted, where D is distance, but length just needs to be any linear measurement where we can relate one to the other shape. So we're told the ratio is 2.5, so we can fill this into our table. From here, we can now work out the area ratio and the volume ratio after. Just remember units. Length is going to be measured in centimeters. Area is measured in centimeters squared. The key word there is squared. So I can go from the length ratio to the area ratio by squaring both of these values. So 2 squared gives 4 and 5 squared gives 25. In a similar way, I can find the volume ratio between these two shapes by taking the linear ratios and cubing, because again, remember, the units of volume are in centimetres cubed. So the cube there, the linked language, is a nice clue to remind us what to do to go from one row to the other. So to go from the length ratio to volume ratios, we're going to cube both of these numbers. So 2 cubed gives 8 and 5 cubed is 125. So we need to work out the volume of solid B. This tells us if, big if the volume of A were 8, the volume of B would be 125. But the volume of A isn't 8, it's 12. So we need to scale this number from 8 up to 12. So we know what we're aiming for, so I'm just going to stick 12 in purple to denote we're still talking about volumes. I need to get from 8 to 12 by multiplying by something. So before recording this, I was thinking I could just tell you to just multiply by 1.5. It's the same plus half again. But I think maybe an easier way might be to divide both of these values by 2 first to get 4 for volume of A. Then after that we can triple both values. So to scale to 12, my first suggested step is we can half both of the numbers in this ratio, divide them both by 2, half of 8, that's easy, that'll give us 4, and half of 125, I would suggest think of it in terms of money. Imagine splitting £125 between you and your best friend evenly, you'd both get £62.50. Use bus stop division if you want to just verify that for yourselves. But after dividing by 2, we should get the ratio as 4 to 62.5. Then to go from 4 to 12, we can just multiply by 3. So finally, multiplying both by 3, the volume of solid B would be 62.5 multiplied by 3. 60 multiplied by 3 is 180. 2.5 multiplied by 3 is 7.5. Putting those two bits together, the volume of B will be 187.5 cm cubed. And just to emphasize that, final line, the volume of solid B must therefore be 187.5 cubic centimetres. Question 14, we've got a mixture of fractional indices and also negatives. So we need to work out the value of 27 to the 2/3 plus 1/2 to the minus 3. Because you have a fractional power here, I'm going to just use a visual reminder. If I've taught you before, this will be no surprise. If I've not, you might be thinking, have I lost my mind? I'm not, well, not quite yet. Flower power. So this just reminds me what to do first when talking about fractional indices. Do I deal with the 3 first or the 2? Well, think about the life cycle of a plant. Where does it begin? Well, clearly, the roots come first. So that's to say that we do the bottom bit of the fractional power first, and that is the root. So the bottom number is the root, and we do that first. After the root grows the flower. Flower rhymes with power, and that comes after the roots. So the top number is the power, and we do that last, after doing the root. So I'm going to think of this as 2 separate steps. So the first bit here, 27 to the 2/3. So 27 to the 2/3, the bottom number is a 3, and that means a root. So I'm going to cube root first. I'll square after. So the cube root of 27, what number times itself 3 times gives 27? That, of course, is 3. So I've done the cube root. I've done the bottom number. Now the final thing is to do the top number, which is 2. In other words, I'm now going to square what I've got after taking the root first. 3 squared, of course, is 9. In a similar way, I'm going to work out a half to the minus 1/3 next. So my suggestion here is to forget the negative and think about what the negative power would be last. First of all, let's just imagine what a half just cubed would be. Well, a half cubed, just multiply the top by itself 3 times, so 1 times 1 times 1 is 1. Then 2 cubed, 2 times 2 times 2 is 8. So if a half cubed is 1/8, we can work out from that what a half to the negative power is. If we know what the value is to any power, that same value to the same power made negative is always a reciprocal of when the power was positive. So a half to the minus 3 will be the reciprocal of 1/8, which is 8 over 1, which of course is just 8. So these are the bits of information we're going to use to tackle this question. So 27 to the power 2/3 plus a half to the power minus 3, well 27 to the 2/3, we've worked out that's 9, and then a half to the minus 3, that of course is just 8, so our final answer is going to be 9 plus 8, which gives 17. Question 15, an object falls from rest. So here's a distance time graph for the distance d meters fallen by the object t seconds after it starts to fall. Work out an estimate for the gradient of this graph at t equals 3. You must show how you get your answer. So working is required. You can't just write down a number and hope for the best. So gradient. Well, gradient normally relates to straight lines. This is not a straight line. We are told, though, we need to find the gradient of the graph when t equals 3. So if I just put a red dot about where we're trying to work out the gradient of this graph at, we're trying to find the gradient of the graph here. So what we need to do is actually draw on a tangent line at this point. A tangent is a line which just touches the curve, just scrapes it at one point you're interested in. So we need to do a straight line that just touches the curve at 3 and then bounces off again. So it's going to be a line going in this sort of direction, which I'm going up and down in. So it's going to go like this, just touch and go off again. Now for GCSE knowledge, it's not an exact science, so best estimate will be allowed. Here is my tangent in blue. So yours should be a similar sort of slope to that. Make it longer if you'd like, but don't make it so short that you're measuring in millimeters. Make the tangent line nice, big and clear. If this isn't big enough for you, by all means make it longer. So now we've got our tangent line, we can now work out the gradient of this blue line, which is the tangent. To do that, I just need to pick 2 nice points of my choosing. By nice, I mean ideally a point that goes through the corner of one of these squares so we can identify its precise coordinates as accurately as possible. So the 2 points I'm going to pick, I'm going to just highlight on with purple circles, very small. So a point there and one there. So between these 2 points, to calculate the gradient of a tangent, I need to work out the vertical change between these 2 points and divide that by the horizontal change between these 2 points. So I can do that now. So gradient of a tangent that's going to be the change in y divided by the change in x. So this bit here, that's at a height, well that's 50. Each of these little squares going up must be worth 5 units. So if that's 50, that's 75, that'll be at 80. So that's 80. And the lower point here, if that's 50, that one's slightly lower, must be 45. So the change in y is 80 minus 45 essentially. Now what we can do is work out the change in x in between these 2 points. So x here, so if it's a different colour, at this point here, that's where x is 4.5. At this point, that's where x is 3.1. So the change in x is 4.5 minus 3.1. So we can neaten this up. So 80 take away 45, that's 35. And 4.5 take away 3.1, that's going to give us 1.4, like so. Now this looks a fairly awkward fraction to deal with, but actually if you get the decimal for a second, 35 and 14, these are both multiples of 7. So depending on what numbers you get, you might be fortunate enough to get simpler numbers. I'm just going to show you what to do if you get some awkward numbers like this. I would suggest to multiply by 10 to get both of these numbers whole. So in my case, times them by 10, that gives me 350 all over 14. Because these are in the 7 times table, I can then divide both bits by 7. So 350 divided by 7 gives 50. 14 divided by 7 gives 2. And 50 over 2 gives 25. So, as I've said before, you may have drawn your tangent differently, and that's absolutely fine. If you've drawn your tangent differently, you just have to draw it on, pick 2 points, evidence clearly you found the gradient, change in y over change in x. You need to go through the same motions, even though your numbers might be different. You need to end up, to get full marks, with an answer in between 22 and 28 inclusive. If your answer is outside of 22 to 28 inclusive, you will lose some accuracy marks, although you can still get your method marks from working out your gradient of your tangent. Question 16, we have an iteration formula, which is quite rare for non-calculator papers, but I suppose we need to expect the unexpected. So what does this one say? Well, we've got start of year n, the population of some species of animal is p subscript n. And at the start of the following year, the population of the same species is given by this recurrence relation. So p subscript n plus 1 equals some number k multiplied by p subscript n, where k is some positive constant. I'll explain what this means in just a second. So the population of the species at the start of year 1 was 8 million, and the population of the species at the start of year 2, it's gone down to 6 million. We need to work out the population of species at the start of year 3. So the main thing here which causes confusion is these subscripts, this little n and this little n plus 1. All this means is knowing that n plus 1 is literally just 1 bigger or 1 higher than n. All this means is the population for 1 year after this year's is just going to be some k multiplied by the population of the previous year. So all it's saying is we can generate or work out the population for the next year by taking the previous year's population multiplied by a certain something. All we need are 2 consecutive years. So n could be 2, then n plus 1 would be 3. And here, what we've got is n being 1, and then n plus 1, well, that's the start of year 2. So we do know information about 2 consecutive years, year 1 and year 2. So for part A, how does this help us? Well, we're told at year 1 it's 8 million, and year 2 is 6 million. And so what we can say here is we can let p subscript 1 be 8 million, because that's the population for year 1, and p subscript 2, population at year 2, is 6 million. So we can just substitute in 6 for this one and 8 for that one. So essentially, our recurrence relation using year 1 as p1 and year 2 p2, population of year 2 is k multiplied by the population for year 1. But we can just infill the values. So p2 is 6, p1 is 8. So if we substitute those values in, we get 6 equals k times 8. Then to isolate k, we can divide both sides of this by 8. Therefore, k must be 6 over 8. In other words, k is 6/8, which of course is 3/4. We then have our complete equation. Now we know what k is. So the full equation is Pn plus 1 is 3/4 of Pn. So the next year's population is just 3/4 of what it was for the previous year. So we're going to lose 1/4 of the previous year's population each and every time. However, for part B, something changes. But before we get to part B, we need to finish off part A, don't we? So work out the population of this species at the start of year 3. And so P3 will be 3/4 of P2. So using the same formula again, this time going for P3, comparing it to P2, I just need to work out 3/4 of the population of year 2. So I do 3/4 of the 6 million. So 3/4 of 6, because the answer gives it in terms of millions, or 1/4 of 6 is 1.5, so 3/4 is 4.5. So the population at the start of year 3, P subscript 3, is 4.5 million, essentially. But the answer line gives millions, so just write 4.5 on our answer line. It then says for part B that at the start of year 5, the value of k is increased by 0.3 to a new constant value. So the value is not changing, it's a constant still. Louise thinks that from the start of year 5, the population of the species would then increase year on year. Is she correct? You must give a reason for your answer. Well, before anything's changed, look what's happening currently. Year 1 was 8, year 2 was 6, year 3 was 4.5. Currently, the population is decreasing year on year because this value of k is 3/4. It doesn't really matter what it is specifically. The main thing is it's less than 1. It's a fraction. So because it's 3/4, we're losing 1/4. If it was 2/3, we'd be losing 1/3 each time. The main thing is it's decreasing because before anything happens for part B, k was less than 1. However, if we now take our initial k, which was 3/4 or 0.75, and add 0.3 onto it, then what would happen here is that would become 1.05. So is Louise correct? Yes, she is. Because k had become something greater than 1, so p will always rise as we're multiplying the previous value by more than 1. There's a few different ways you could word your explanation for part B to still get full marks. This is just how I'd word it, something along those lines. Check the official mark scheme, but essentially you need to make reference to the fact she is right, and the reason why is k has now gone to a value more than 1, and if you multiply something by a value which is greater than 1, of course it will keep increasing. Question 17, factorise 6x squared minus 5x minus 4. I'm just going to show you my strange method for doing this. So chances are, if you've not been taught by me, you don't know this method, but I'm going to use it because I love it and I make no apologies. So if there's a coefficient of x squared, just check first if we can factorise out any of these numbers first. Is there any number apart from 1 that we can divide into 6, 5 and 4? No, there's not. So using this method, what we do is we pretend, essentially, the 6 disappears. We do 6 times the n number, and then forget that 6 ever existed for the time being. And we're going to think of it as just a single x squared minus 5x minus 6 times the 4, so minus the 24. We now factorise this one as you would do a standard normal quadratic. So we need two numbers that multiply to negative 24 but add up to negative 5. With a bit of care and thinking, hopefully you'll get the values positive 3 and minus 8. However, this 6 needs to be remembered. This 6 we now put back underneath the numbers inside each bracket. So we put the 3 on top of the 6, we put the 8 on top of the 6. Now, if we can, we simplify both of these fractions. 3/6 simplifies to a half, minus 8 over 6 simplifies to 4/3. At this stage, if any denominators remain in these fractions, we just shove them to the front. So all we need to do now is put the 2 in front of the x and put this 3 in front of the x in that bracket. So then what we have is 2x plus 1, 3x minus 4. So that's going to help us now for part B. So part A, that this thing here, we've shown factorizes into this. Now what we need to do, the key word here is hence. In other words, use what we're doing in part A to help you to solve this. So I need to solve this quadratic inequality. 6x squared minus 5x minus 4 needs to be less than 0. So I'm going to use the factorized form of it. So 2x plus 1 brackets 3x minus 4 needs to be less than 0. So what we can do here, first of all, my suggestion would be is to find the critical values which would make each bracket exactly equal to 0. So the critical values we can write down now. Because the key thing is 0 here. So one value, what makes this bracket equal to 0, would be x being equal to minus a half. This method here is useful for this step because your solution is essentially given in the penultimate line of this factorization method. So the critical values are actually these values here where their signs switched. So if critical value is x being minus a half, and the other one, what value of x would make this bracket equal to 0? I'm basically solving when 3x minus 4 is equal to 0. If you want to do that, you can. Or just looking here, take this value and switch its sign, x would have to be positive 4/3. I'd always suggest when solving a quadratic inequality, obviously make one side 0, and then imagine a graph. In fact, I would suggest sketching a graph. 6 is a positive value, so it's going to be a positive, happy-looking quadratic like this. And so we're trying to solve when it's equal to 0. Here's a cheat sketch. Didn't sketch it, I just nicked this from a website, essentially. So because I'm wanting it to be less than 0, I'm wanting this bit underneath the x-axis where it's negative. And so these two values here relate to these 2 points. That's where x is minus a half, and this one over here, that's where x is equal to 4/3. I want x in between these 2 purple dots. I want x to be more than minus a half, all the way up to, but not including, 4/3. So because I want this yellow portion of a graph, which is in between the 2 dots, is something in between 2 things I think of it as a sandwich. So the answer to this is going to be an inequality sandwich with x in the middle. So we sandwich x in the middle because we want our values of x to be in between these 2 critical points. So I want x, and copy this symbol here, x needs to be less than 4/3, but also at the lower end, x needs to be more than minus a half. And the symbol always goes the same way. And that's our answer. If you really wanted to, you could do it as 2 separate inequalities. You could say x bigger than minus a half and x less than 4/3. But it's easier, if possible, and you're confident enough to put it into one single inequality with x in the middle. Question 18 is a probability question, and it could be done using a tree diagram, but I'm going to show you how a tree diagram isn't always necessary. If you want to do one, you can. By all means, I invite you to do so if you want, but I'm just going to show you that, in my opinion, a tree diagram A isn't necessary, and B can actually add in an extra unnecessary layer of confusion. So keep it as simple as possible is my suggestion now. So anyway, we've got two spinners, each one spun once. First of all, it says the probability that a spinner lands on red is 1/4. So never ignore the obvious. So this is saying the chance it lands on red is 1/4. What it's therefore implicitly saying is the chance of it not being on red is going to be the other 3/4 of the time. So 1/4 of the time A is going to be red, the other 3/4 A is going to land on not red. The next thing we're told is that the probability that both A and B land on red is 1/4, is 1/24. So then we need to find afterwards a probability that one lands on red and the other does not land on red. So let's just hone in on this information here. And I've highlighted the word and. The probability that both A and B land on red is 1/24. With probability, almost universally, the word and implies multiply two probabilities together. And so taking this, what we can do is say the chance that A is red multiplied by the chance that B is red also, because and implies multiply, is 1/24. However, we know already the chance that A is red. A being red, that's a 1/4 chance. So we can sub in the probability of A being red as 1/4, then we can focus in on what the probability of B being red would have to be. So the chance of A being red is 1/4, so 1/4 multiplied by probability of B being red is 1/24. So if I just forget this for a second, 1/4 multiplied by what would give me 1/24? Well, when we're multiplying something together, imagine this number's a fraction. To multiply two fractions together, we've just multiplied the tops and multiply the bottoms. So 1 times 1 would give 1, and 4 times 6 would give 24. So the fraction here that makes this work has to be 1/6. So therefore, the probability that B is red has to be 1/6, because 1/4 times 1/6 gives 1/24. You could, if you want to, multiply both sides by 4 and think of solving this in a different way, but ultimately your solution and conclusion should be the same as mine. The chance of B being red is 1/6. Therefore, in the same way as what I mentioned before, we can then deduce the fact that B is not red. If B is red 1/6 of the time, therefore the other 5/6 of the time is going to be not red. So it's always worth making a note of that. We've now got the raw ingredients to actually answer the question as it's been asked. So if I just highlight in green the actual question, work out the probability that one is going to be red and the other is not, I'm just going to reword this in a slightly different way to emphasize how the use of language can help with probability questions. So the chance that one is going to be red and the other's not, well, there's two different ways that could happen. So to be careful and logical, we can word this clearer, something like this. What this is saying is, work out the probability that A is red and B is not. So that's one scenario here. So option 1, A red and B is not. Or the second scenario, A could be red, not red, sorry, and B is the red one. So two different possibilities to consider. And just as I highlighted the word and in yellow, so I'm going to do the same to the word or in a different colour. I'm going to highlight that one in green. So just as the word and implies we multiply probabilities, the word or implies we add probabilities together. So putting this together into a cohesive piece of sort of logic to help us answer the question, the chance of one being red and the other not is a chance that A is red and B is not red, or, hence the plus symbol, the probability that A is not red and B is the one that is red. So and implies multiply, so we can now add in more information. We know these probabilities as well, so we can just substitute in and solve. So chance of A being red is 1/4, and, so multiply chance of B not being red, which was 5/6, or, so add the chance of A not being red, 3/4, multiplied by the probability of B being red, which was 1/6. So if you look at this now, this is actually reduced to a fairly simple question. We're just multiplying fractions when adding. So first of all, a quarter times 5/6. 1 times 5 is 5, 4 times 6 is 24. This becomes 5 over 24. This will become 3 over 24. So we've got 5/24 plus 3/24. Both denominators are the same, so we can just add, and that gives our final answer of 8 over 24. With probability, you can leave fractions unsimplified. That's okay. Although, as a general rule, if you can simplify, you may as well do so if you're confident to. You should probably see and probably know yourself that 8 over 24 does simplify down to 1/3. So either of these underlined fractions are suitable final answers to score you full marks. Question 19, we have a graph of sine x. So y equals sine x from x being down to minus 180 degrees to positive 180 degrees. And for part A, we have to find estimates for the solutions of where sine x is 0.3 in the range of x being in between minus 180 and positive 180. And so if y equals sine x, we're basically trying to find where sine x equals y, where y is 0.3. So if I imagine now a horizontal line at 0.3, which is 3 little squares up, we can then see whereabouts our curve crosses this line. So here's a line where y is at the value of 0.3, and we can see here our curve cuts it at 2 different places. So there's an estimate here and an estimate there. So if I just add these onto the diagram with these red dots or circles, I can then think about how to estimate that. And I do stress it's an estimate, so don't worry if your figure isn't exactly the same as mine. So looking here, what I'd suggest doing is figuring out, reading from left to right, how many units each little square going along is worth. So 5 squares, 10 squares, 15 squares gets us to 90 degrees. It must be that each little square is worth 6 degrees. So this one here looks about 17 or 18 degrees-ish. This one over here, 6, 12, 18 degrees would be this line. So it's just before 18, maybe 17 or 18. This one over here, that would be 150, 156. This would be about 162 degrees. So the two solutions, reading down using these blue lines here with arrows heads, you should find roughly x is 17, 18-ish, and x is 162 degrees. So answers fairly close to that will get you the marks. If you are wondering, well, how close do I need to be to get the marks? The first value here needs to be in between 15 and 18 degrees inclusive, and this value here needs to be in between 162 and 165 inclusive. So as long as your estimates are within those bounds, you'll get full marks. Part B, we need to write down a value of x such that sine of x plus 20 is 0, for x being in between minus 180 to 180. Now, what this question is difficult for is that in the brackets, it's not just a simple x or y, it's x plus something. So I'm just going to think about this bracket as just one whole thing. I'm going to think of this being sine of b, where b is the bracket, equals 0. I'm just saying here as well, that's the answers that should be accepted for part A. For part B, I'm just going to replace x plus 20 and think about it in terms of big B for bracket. So I want when sine of what's in these brackets is equal to 0. So again, similar to part A, I can use a graph to find whereabouts y is equal to 0. Essentially, when y is equal to 0, it's on the x-axis. So where does this curve cross the x-axis? So if I just highlight the x-axis in green, like so, you can see here it's going to cross at 3 different points: minus 180, 0, or 180 degrees. So sine of whatever's in my brackets is equal to 0 when what is in the brackets is equal to either minus 180, 0, or positive 180. These 3 points here. So my bracket needs to equal one of these 3 different values, of course. However, the bracket was actually x plus 20. So what this means is the brackets, which are x plus 20, equals minus 180, 0, or 180. I'm not really interested in the brackets, I'm only interested in the value of x. So this equation is no good to me until I just have x on its own as a subject. So what I could do here is subtract 20 from both sides of this to isolate x and to get my solutions. So if I take 20 from both sides, I then get that x must be either minus 200, minus 20, or 160. However, our range of x needs to be in between minus 180 and 180. So minus 200 is too negative. We can't use this as one of our values. And part B does say write down a value, not both. So discounting minus 200, because it's too small, it's less than 180, we could either put down x is minus 20 or x is 160. So discounting that leaves us with two different choices for our answer. Either put x is minus 20, or x is 160. Question 20, again still on the same topic of trigonometry and trig values. This one I think is borderline unreasonable. This is a real deep challenge and test of your understanding. This would be a fairly good question to ask for an A-level student. I really, truly mean that. We've got a triangle ABC. First of all, note it's clearly not a right-angled triangle, so it's not going to be SOH-CA-TOA. We need to find the size of angle ABC. So we need to show all working as well. So if it's not a right-angled triangle, it's either going to be 9 times out of 10, the sine rule or the cosine rule. We know it's the cosine rule if we know each and every side and we're trying to find an angle. So this is going to be the case where it's the cosine rule. Another thing you can consider is it would be a sine rule question if we know a side and an angle opposite to it. Because we don't know that information, we don't know a side and opposite angle pairing, it's not the sine rule, therefore it will be the cosine rule. And this is the cosine rule as it will be presented to you in the exam. So a squared, where a, b and c are the lengths of sides, a squared is b squared plus c squared minus 2bc cos a. And this question is even more awkward because to find the side, little a is a subject, and the angle here, big A, as well, is used for finding an angle. However, ABC is this one here, it's the angle at B. So I've been in two minds for a long time, but now I'm feeling the best idea to minimize mistakes is to just relabel any triangle you're given and just label. If you're trying to find a side, label the side you're trying to find as little a. If you're trying to find a particular angle, label that angle big A, even if the question labels it something different. So because I'm trying to find angle ABC, I'm going to term that my big A. So even though it says B there, I don't care, I'm going to call that one big A. Then in any order, doesn't matter which, the other two need to be angles B and C. So I'm just going to add these in like so. You might think, well, C I could have stuck as C, but I'm just emphasizing it doesn't matter. The only thing that matters is big A is the angle you're trying to find, or little a is the side you're trying to find. Because I'm interested in the angle, I'm interested in this big A. Next, label the sides. Opposite the angles, we label the sides with the same letters in lowercase. So opposite big A is little a. Opposite big B is little b. Opposite big C is little c. So labeling the sides like so, there we've got it. So because we're trying to find an angle, we need to get this big A as a subject, or at least cosine of A, or cos A. So at the minute, this is negative 2bc cos A. So what I'd suggest to do first would be to add 2bc cos A to both sides of this equation. If I do that, the left-hand side is going to become 2bc cos A plus the a squared, which is already there, equals b squared plus c squared. I can then isolate the 2bc cos A by subtracting a squared from both sides. That will then give me that 2bc cos A is b squared plus c squared minus the a squared we've just subtracted. I can now get cosine of a on its own. Cosine is the full name for cos, by the way, if you're wondering. I can just divide everything by the 2bc in front of the cos of a. So dividing everything by 2 lots of bc, I see that cos of a is b squared plus c squared minus a squared, all divided by 2bc. The next thing we need to do is just to actually infill and substitute in the values we know. So we know that b is 10, c is 5, and a is 5 root 7. So subbing these into this formula, cos a is 10 squared plus 5 squared minus 5 lots of root 7 all squared divided by 2 times b, which is 10, times c, which is 5. We can then simplify that. So 10 squared is 100, 5 squared is 25, and 5 root 7 all squared, I need to square the 5, which gives 25, and square of root 7, which just gives 7. All of that is going to be divided by what 2 times 10 times 5 is, which is exactly 100. I can now simplify the top. 25 multiplied by 7 is 175. So 125 take away 175 gives us minus 50. So this fraction is the same as minus 50 over 100, and that of course simplifies down to minus a half, or minus 0.5 if you prefer. Now this isn't to say that the angle is minus 0.5, it means that the cos of that angle is minus 0.5. And why I'm saying this question is almost unreasonable, I don't mean that literally, it's just a very challenging question and tests your understanding a lot, is knowing the trig values from 0 up to 90 degrees for all multiples of 30 degrees and 45 is one thing, but what you need to do for this question is to be able to extend that for any multiple of 30 degrees or 45 degrees. So what teachers, including myself, should be telling you is that you have these exact trig ratios for sine, cos and tan for 0, 30, 45, 60 and 90 degrees. But of course, if you look here, all of these sines, coses and tans are all non-negative. None of these are negative values, but we've got the cosine of an angle we're trying to find as being minus 0.5. So what you need to do here is either to have a good feel of symmetry or patterns, or ideally to have a feel or knowledge of what the graph of cos x looks like from 0 to 360 degrees. It starts at 1, goes down to 0, but then it goes down to minus 1 as well, like a wave, before coming back up again. So ideally, knowing this graph would be really, really useful to you. So cos of 0 is 1, cos of 30, that one's root 3 over 2, look. Cos 60, that's going to be, or cos 45 rather, missed one out, that's root 2 over 2. Cos 60 is a half, cos 90 is 0. What you need to appreciate is that each of these points here mirrors and becomes its negative counterpart underneath this curve here. So 90 degrees, that's where it's 0. So these two, they're just anchored at 0. But for example, 60 degrees, that'll have a counterpart down at 120. As would, for example, 45 degrees, which is 45 degrees before 90, that'll have its counterpart for an angle which is 45 degrees after 90, in other words at 135. So that one will be the negative version of what it was when it was 45 degrees, therefore this one here, for example, would be minus root 2 over 2. But what we're interested in for this question is minus 0.5. Well, that's positive 0.5 when we've got 60 degrees, therefore we'll have negative 0.5 when it's 30 degrees after 90, not 30 degrees before, and that's going to be giving us a value of 120 degrees. And I do say again, this question is very hard. I think if you got to cos of A being minus a half, you've done exceptionally well. I don't know how many percentage of people, how many candidates got full marks for this, but I would imagine it would be very, very much under 10%. Anyway, just to conclude, therefore we can say A, which of course wasn't the actual angle we were wanting. Well, it was, but it is angle ABC. So using that knowledge, if cos of A is minus 0.5, A itself must be 120 degrees. In my opinion, that's the hardest question on the entire paper. Question 21. On the grid, draw the graph of x squared plus y squared equals 169. When you see an equation like this, where it's x squared plus y squared together on the same side and a number all on its own on the other side, you need to remember this is the equation of a circle. The equation of a circle always has the form x squared plus y squared equals the radius of that circle squared. This is a non-calculator paper, so be thinking these numbers should be nice and easy to work with within reason. If this is a number squared, what number squared would give 169? Well, that's actually the same as 13 squared. And so what we've got here is the equation of a circle centered at the origin with radius 13. And so the first thing we need to do is just ideally using a compass and protractor, and put your compass needle at 0 and draw a circle radius 13. So here's one I made earlier. Part B, we now need to use this graph to find estimates for the solutions of these simultaneous equations, and it does say use your graph. So don't try and be too clever with the algebra, use the graph as the question says. So we've got the graph of a circle, that's all good. One thing we've not got is the graph of this straight line drawn. Now any straight line, students are probably sick of me saying, what's the standard equation of any straight line? And it's y equals mx plus c. Not 2y, not 3y, just 1y. So I can divide both sides of this equation by 2 to get it into a better form. In other words, y equals 3 over 2x. In other words, the gradient of this one is 3 over 2, or 1.5. So for every 1 unit I go along, I go 1.5 units up. So for example, if I went 4 along, I'll be going 6 up. So the straight line, 2y equals 3x, needs to be drawn like this. So now, to find estimates of this equation, these simultaneous equations rather, I can now just simply look at where these two curves, well, the straight line and the curve, cross over each other. So we've got a point here and a point there. So if we look at this very carefully indeed, this point here, that's when x is 6. Each little square going along is worth 0.4 of a unit. So 6, 6.4, 6.8. This is where x is 7.2. So x is 7.2. And the corresponding value for y is, that's 2 little squares up. So on this scale, again, each little square going up is again 0.4 of a unit. So this is where y is 10.8. So that's one solution set. Or the other coordinate pair down here, we've actually got the same values, just made negative. So that's what x is minus 6, minus 6.4, minus 6.8, minus 7.2. So it could be that x is minus 7.2 and y, if you look there again, it's going to be minus 10.8. So those are the two different values to solve the question as asked. Now we've got one more, the final question on the entire paper, question 22. So for question 22, we're talking about geometric sequences. So we've got one second term of a geometric sequence is 3 plus 2 root 2. The third term is 13 plus 9 root 2. Find the value of the common ratio of a sequence and give your answer in the form a plus root b, where a and b are integers. You must show all your working. Information overload. Let's start with the basics. What on earth do we mean by geometric? So what's a geometric sequence? Well, a geometric sequence, put simply, is one where the next term along is a previous term multiplied by the same number each time. So the numbers might be doubling or tripling. Alternatively, it might be halving or being quartered each time, as long as it's the same multiplicative relationship from one term to the next. So let's just imagine what a simple geometric sequence is to get the idea of what the question is actually asking us to do. So let's think about an easy geometric sequence. I think the easiest one is just where you take the number 1 and keep doubling it. So this one is a geometric sequence. 1, 2, 4, 8, 16, 32. It's geometric because each term is one before it doubled. So this one, because we're multiplying by 2 as we go along, that's got a common ratio of 2. In plain English, the common ratio is just how many times one number is compared to the number before it. To get the common ratio, you take one term and divide by the term that comes immediately before. So 32 divided by 16 is 2, as is 16 divided by 8, and so on. So that's how you find the common ratio. It's one term divided by the term that comes immediately before it. And we know two such terms. We know the third term, and we know the term before the third, which is the second. So now we know what we need to do, we can begin to tackle it. The common ratio of this sequence is going to be the third term divided by the second term. In the same way here, the common ratio of 2 is worked out by taking one term, for example 4, and dividing by the term that comes immediately before it, for example 2. 4 divided by 2 is 2. So let's set out the problem. So just to clarify what I've said, the next term is just the common ratio multiplied by the term before it. We know the second and third terms. So the next term, the third term, is whatever the common ratio is multiplied by the previous term. So that's what we've got. 13 plus 9 root 2 is the ratio multiplied by 3 plus 2 root 2. So to get the ratio on its own, I need to divide everything by 3 plus 2 root 2. That then gives me that the common ratio, which I'm trying to find, is 13 plus 9 root 2, all divided by 3 plus 2 lots of root 2, which is, like I said before, the common ratio is just any term divided by the one that comes immediately before. In this case, the third divided by the second. But our answer needs to be in the form a plus root b. So although we've got maybe a mark here already, it's not in its simplest form, nowhere near. For example, this here isn't a fraction, this is. So we need to get rid of this denominator. We certainly want it to be rational at the minute this is irrational. So we need to remember how to rationalize the denominator. What we do in these cases is we multiply both the top and the bottom of the fraction by the denominator with the sign switched. So we're going to multiply both top and bottom by 3 minus 2 root 2. So I'm going to use a grid method for this, both for the numerator and the denominator. So if I multiply the denominator first, 3 plus 2 root 2 by 3 minus 2 root 2. So using the grid method, I can pick any box as I wish. If I go for the top left first, 3 times 3 is 9. This one next, 3 multiplied by 2 root 2 gives 6 root 2. Next, 3 multiplied by minus 2 root 2, that gives minus 6 root 2. And finally, 2 root 2 multiplied by minus 2 root 2. Well, 2 times minus 2 is minus 4. Root 2 times itself is 2. So I'm going to get minus 4 times 2, which gives minus 8. If I simplify this, 6 root 2 and the negative 6 root 2, they'll cancel each other off. So I'll just be left with 9 minus 8, which is exactly 1. So the denominator, after rationalising it, will become 1. Now we need to multiply the numerator by the same thing, by 3 minus 2 root 2. So this value first. 3 times 13 gives 39. 3 times 9 root 2, that gives 27 root 2. 13 multiplied by minus 2 root 2, that gives negative 26 root 2s. And finally 9 root 2 times minus 2 root 2. 9 multiplied by minus 2 is minus 18. Root 2 times itself is just 2. So that's going to give me minus 18 multiplied by 2, which is minus 36. Simplifying this, for normal numbers, 39 take 36 becomes 3, and 27 lots of root 2 minus 26 of them will leave me with exactly just one lot of root 2. So I'm going to get 3 plus root 2. So the ratio, the common ratio, which was this, I can now simplify to being 3 plus root 2 on the top, all over 1. So although I've pretty much got my answer here, it's not answering the question as I need. It needs to be a plus root b with no denominator. Now luckily the denominator of 1 is the easiest denominator we could wish for, because anything over 1 is just the same without that denominator even being mentioned. In other words, 3 plus root 2 all over 1 is just the same as 3 plus root 2. That's in the form of a plus root b. A is 3 and b is 2 in our case. So I've answered the question as we needed, and that's the last question, so I've answered all the questions in the paper as required. I hope you found that useful, and I hope you stuck at it for as long as you needed to and got something from it. Thank you for tuning in, I do appreciate it. Any suggestions or comments or feedback, please drop me a line, and take care of yourselves until next time.